All right, so today we're going to talk more about how to display data. We're going to talk about something called a histogram. And a histogram is a bar graph looking chart that shows frequency of data values in intervals of the same size. And just like a box and whisker plot, histograms are really helpful when you want to show the shape of a distribution. Remember, shape means is it skewed or is it symmetric? So I underlined kind of the two most important parts of a histogram. The intervals on your x-axis right here have to be of the same size, or else your data wouldn't necessarily be accurately represented. And then when we're talking about frequency of data values, we're looking at how many times did a value or a range of values appear. Okay. So when you're talking about shapes of distribution here, so we've got, again, skewed left, symmetric, and skewed right. I think it's a little bit easier to kind of picture this histogram as what it would look like as a box and whisker plot. Because a lot of times, like, your brain can kind of confuse you, and people will say, oh, the bars are really tall on the right, so that must mean that it's skewed right. But if you think about it as a box and whisker plot, if we've got taller bars on the right, that would mean that there's more data over here. And on a box and whisker plot, when we've got a lot of data that's close together, we have shorter boxes and shorter whiskers. So when we've got a lot of tall boxes, I keep saying boxes, bars, over here and not as many over here, that means you've got a few low values that would be pulling your mean down. And so you'd say, all right, well, I've got a couple values down here, but most of my data is over here. And so then we'd be able to say, oh, that's a longer left whisker, so that's why it's skewed left. And whenever your data is skewed left, that means your mean is going to be lower than your median, again, because your minimum value is pulling your mean down. Symmetric is going to be similar to box and whisker. It doesn't need to be exactly bell-shaped, but it should be, you should have your taller bars in the middle, and then you should be going down on either side. And then if your values, or if your data is skewed to the right, then you've got, like, let's just say 75%, right? 75% of your data is on the left side. That's where a lot of your data is. But then you've got some of these bigger values that are going to pull your mean higher than the median. So your mean would be greater than the median. Because your maximum value is bigger than most of your data. Okay. My son is hoarding toys up in his room. All right, and so we're going to look at a couple of examples. One kind of where the majority of the work is done for us, and then one where we have to do a little bit more. And again, I'm re-recording this, so I couldn't erase this all the way, but I didn't want to go all the way down to our basement to print a new one. So laziness is taking over. All right, so you always want to make sure you label your histogram just as you would a graph, a box and whisker plot, whatever. You should be able to give this to someone to analyze, and they should have no question about what they're looking at. And so when you're looking at your data over here, here are your intervals. Notice they're all the same size. The difference between the highest and lowest value is 7. Right, so our range is going to be 7 tickets. And so what this means is that between 1 and 8 tickets were sold 5 times. Between 9 and 16 tickets were sold 9 times, and so on and so forth. So your intervals are always going to go on your x-axis. And in this case, the intervals represent the number of tickets sold. And then your y-axis will almost always be your frequency. How many times did that occur? And so when you are making your bars here, there's a couple of ways you can do that. I'm going to focus on one that people usually have a little bit more trouble kind of like understanding at first. When you're making your own histogram, I don't really care how you do this as long as it's correct, but I want to make sure you can kind of interpret both ways. So one thing that's a little bit easier is to just take these ranges and put them down here. So we have how many? 1, 2, 3, 4, 5, 6, 7 intervals. And you want to make sure that, just like when you make your number line, they're evenly spaced out. So this little graph actually already has a couple of tick marks on there. So we need 1, 2, 3, 4, 5, 6, 7. Okay, so again, the easier thing to do if you're making your own is to just go 1 to 8, 9 to 16, and so on and so forth. But a lot of times that can get a little bit crowded, and so to simplify it, you'll just see like one number here, 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 and here. But what you would see would be something like this: 1, 9, 17, 25, 33, 41, 49, and 57. Okay, and so what you have to understand is what this means about your intervals. So when we make our bars, the left number on your bar is always where your interval starts. The right side of your bar is going to be where the next interval starts. So you still need to be able to understand that this first one is actually between 1 and 8. This is between 9 and 16, 17 to 24, and so on and so forth. So again, the left number is where your interval starts. The right number is where the next interval starts. So if I were to give you just this without the table, and I asked what's the maximum number of tickets that were sold, you would say 56, because 57 is the right side of this bar, so that's where the next interval would start if you had a next interval. Okay. All right, and so then our frequencies are going to be our y-axis. So just like with box and whiskers, we need to decide what we want our interval to be. This, you should always start at 0. So your x and your y-axis sometimes will have a different starting point. And so I see that my highest is 25. So I'm going to go 5, 10, 15, 20, 25. And you always want, again, remember these have to be evenly spaced. And you want to use as much of your graph as possible. So you don't want everything to be too smushed down here, because then the shape could be harder to see, and it's just honestly not as neat. All right, so our first interval had sold 5 tickets, and then we had 9. I'm going to go ahead and write 9 at the top there since I had to estimate. And then my next interval had 16. And again, I'm going to write that on top of there. Whenever you have to estimate, it's never a bad idea to write that. Next interval had 25. And then down to 20. And then down to 8. and then down a little bit more to 7. Okay. And if this bothers you, you can sometimes be like, I just want to write them on all of them. All right, so there's your finished histogram. When we think about the curve that this would form, I would say that this is pretty symmetrical. It's not exactly symmetric, but your 3 highest bars are the 3 ones that are in the center, and then you are consistently going down on either side. So it's definitely not significantly skewed in either direction. The mean and the median will probably be pretty close. And you can kind of see that too when you look at your frequencies, right? We're going consistently up and then consistently down. And so you can kind of see that before you even graph it. And so when you are looking at those shapes of distribution, we're going to be analyzing similar things in terms of, do we want to use the median? Do we want to use the mean? Looking at how our data is skewed, etc. So if your histogram is symmetric, you can use the mean or the median to describe your measure of center and variation. If you're skewed one way or the other though, you're going to want to make sure you use the median, because since your data is skewed, that means your mean is going to be a little bit higher or lower than your typical data value. Okay. All right, so the next example we're going to look at is one where we would have to do a little bit more work up front. I already had it. I'm not going to erase it. I'll save a little bit of time here anyway. So the data was just randomly in this table. It was not pre-sorted like this one was. So when you're just given a bunch of values, the first thing you're going to have to do is sort it in your intervals. I will always give you the number of intervals and what those intervals should be. You're not going to have to do that on your own. So you just have to make sure that all your intervals are the same, have the same range essentially. So the range of the speeds here is 31 to 35. Okay, so that's a range of 4. So that means my next interval would go from 36 to 40. And when I say range, I mean like not including, like I'm just subtracting the highest and lowest value. So I'm not actually like including 36 or 40. Just doing some math to help that be a little easier. So that I'd go 41 to 45 and so on and so forth until you get 6 intervals. And so then what you would do, and what I did the first time I made this video, was I just went through and I just put tallies where each speed should belong, because this represents the speeds of different cars. So 32, I put a mark here. 53, I put a mark here. 56, I put a mark here. And then I just condensed that a little bit into these numbers. And then I added them together, make sure they matched the total, which was 30. Okay. All right, so now when we are going to actually make our histogram, I'm going to put these intervals on here. So this starts at 31. The next interval starts at 36. The next interval starts at 41. Then 46, then 51, then 56, and that means my last interval, or last tick mark I should say, the next interval would start at 61. So it's always going to be one more than your maximum value. And so then when I look at the frequencies, I see that the highest one is 11, So I should have enough space to just go up by 1. 1, 2, 3, 4. I do. All right, so that's good because that means I won't even have to estimate anything. All right, so let's label anything before we move on. So this is speeds of motorists in miles per hour. Okay, and then this is the frequency. And so then there was only one person going between 31 and 35 miles per hour. 3 in my next interval. 5 in my next. 6. 11. And 1, 2, 3, 4. Okay. All right, so when I go and I think about what that curve would look like, and then it comes down pretty drastically here, my higher bars are on the right side. And then I kind of am going down this way. So I've got really these, would this be like 4 motorists that are significantly lower than the rest, where my peak was right here. So if I think about a box and whisker plot, that means that these values would be making the left whisker longer, which means that this would be skewed left. So you would want to use the median to describe your typical data value. Okay, and so if the speed is 45 miles per hour, okay, well that's the end of this interval right here, the third one. So that means that most people are speeding. And then that's it. Okay. All right, so the last one is another application, looking at a double, like we ended with yesterday. And so if we kind of, without even just looking at this, we should be able, when you're making your own histogram, remember you should be able to hand that to someone. Everything should be appropriately labeled so that they can understand what you're looking at. So I see that my x-axis is the number of emoticon messages, and then this is the frequency of male students and female students. So I can see that only that 14 male students sent between 0 and 9 emoticon messages over 1 week. I can see that 14 female students sent between 30 and 39 emoticon messages over the course of the week. So we're able to interpret it that way. So in terms of the distributions, I see my highest bars for the female students are in the middle, and then we go down on either side. There's not significant pull in one direction or the other. So I would probably say that this is symmetric. Means your mean and your median are going to be pretty close. Whereas the males, they're not sending as many emoticon messages. You guys could use some emoticons in your life. And so this is going to be skewed to the right, right? We've got these 2 to 8 male students that are sending more than this bigger group over here. So my right whisker would be longer. So that would be skewed to the right. And remember, that means your mean would be bigger than your median. So these guys are pulling since our highest value is 39, in this one, that 39 is going to pull the mean higher. Okay. Now, the last thing I really want to talk about is, so when I ask you, in this one especially, right, this one is going to be hard because the mean and the median would be close. So this is going to be more applicable when you're looking at a histogram that is skewed. But if I were to ask you, which bar the median would fall in. We need to be able to figure that out. Now, we don't know the exact data values, but if we understand where the median is, we can use these frequencies to figure out at least the range that it would fall in. So over here, we can see we have 14 in the first bar, 12 students in the second bar. I'm just counting up my frequencies. And then 6, and then 2. So that's what, 26, 34. So there are 34 total students represented in this histogram. So if I were to line up all 34 pieces of data, when I divide that by 2, that means that I get 17 pieces of data on either half of the data. So that means the median is going to be the average of the 17th and 18th value, right? Because we're going to have 17 and 18 in the middle. And so then I can just kind of count and say, okay, well, the first 14 students are in that bar. And then there's 12 in this bar. That means that the 17th and 18th value, because these two bars together represent 26 students, so the 17th and the 18th person will be in that bar. So the median is going to be a value that's between 10 and 19. Okay, so a lot of people, their eyes, again, you hear median, you think center, so they'll say, oh, the median is going to be 19 and a half, because that's halfway between here. But you always have to think about the numbers, not necessarily the look of it, okay? All right, so again, your homework tonight, post it on Canvas. Let me know if you have questions.